This week's groups will be looking at how we draw organic molecules and how we name them. I wanted to do a little kind of preview video on drawing organic molecules to make it a little bit easier when you get to your groups this week. The reality is that there are a variety of ways to draw organic molecules. I'm going to look at a couple of examples here and how we kind of translate those from one to the other. So in this picture, what we see is that we see three different structures all representing the exact same molecule. If we look at these, we notice that we have 1, 2, 3, 4, 5 carbons in the first structure, 1, 2, 3, 4, 5 carbons in the second, and there are actually 5 in the last, the skeletal formula, although we don't actually explicitly see those carbon atoms. And what we want to be able to do is actually translate between these different structures so that if you're given one, you can draw the other two. Now the first one is called an expanded structural formula, or we also call these Lewis structures. This is similar to what we looked at in the previous chapter in drawing out all of the atoms and showing the bonds between them. Now we can draw a condensed structural formula, which is handy because, as you can see, this is a pretty small molecule, but organic molecules get very big, and so being able to write a condensed structure makes it a little bit easier to write out. So what we actually do is we can simplify how we're drawing the structure. And what happens is I'm going to look first at this carbon, and then I'm going to go down here. I'm going to say, okay, it has CH3 because I have a carbon with 3 hydrogens attached. I go to the second carbon, and I see that it has 2 hydrogens attached, so I rewrite that as CH2. The third carbon again, another CH2. The fourth carbon, a CH2. And the last carbon here, the fifth one, we have a carbon with 3 hydrogens attached, so we have CH3. We can also write this even a little bit more condensed by saying CH3, CH2, 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 CH3, basically where we don't put those dashes and or hyphens between the atoms, and this tells us the exact same information. So both of these structures are absolutely equivalent to one another. You don't have to put those dashes in there when you're doing the condensed structure. We're doing it here just to separate the molecules. Either would be considered correct. On mastering, you don't actually put the dashes in because you won't be able to. The last one we'll look at here is the skeletal formula. And when we look at carbon, we get to take the advantage that carbon always has 4 bonds. Always has 4. And what we can do is say, okay, if I look at a carbon atom, say this one here, I'm going to represent the carbon atoms at the intersection of each of these lines. And there's also one at the end of each of those. So now what we have is this skeletal structure that's very fast to draw, and we don't actually have to draw in every single hydrogen atom because we can take advantage of the fact that every carbon has 4 bonds. We know that if I have a carbon here that has 2 bonds, then I know it must also have 2 hydrogens. Carbon here has 2 bonds already to carbon, so it must also have 2 hydrogens. If I look at one of the terminal carbons, it only has 1 bond to another atom drawn in my skeletal structure, so I know it must have 3 bonds to hydrogen because that needs 4 bonds in total. So we can translate these structures among the 3 of these different types. So let's look at how we deal with this with a branched alkane. Similar to what we did before, we look at our kind of bigger structure, our expanded structure here, and what I see is I've got a CH3, CH2, CH with a CH3, my branched group here, a CH2 and a CH3. Now when I draw my skeletal structure, what I want to look for is the backbone, and I see that here I have 5 carbons in a row. So I have 5 carbons in a row here in my skeletal structure. I also see that I have a 1 carbon group attached to the 3rd carbon here. And so I want to show the same thing in my skeletal structure, and I do that by just drawing that single line. I know that the end of this is representing a carbon atom, just as each of these intersections and ends of these lines represent a carbon atom. So I still have the same structure. When I look at this atom here in the middle, this carbon right in the middle, I see that it already has 3 bonds. That means I know it's only going to form 1 more bond to hydrogen, which matches up what I had in my Lewis structure above with the 1 hydrogen to that carbon. Now drawing the condensed structure is a little bit different for these. And the way I look at these problems is I actually kind of read the molecule from left to right. First, I'm going to look here at CH3, and I go down here and I see I've got CH3. I look at this atom, I've got CH2, and I go down to CH2. Next, I have a CH, so I go to CH. And I also notice that I have a CH3 group off to the side, and so I show that here in parentheses. And what the parentheses show me is that this is a group that's attached to the carbon. It is not part of the longer chain, but the parentheses indicate that it's off to the side. Once I've put that group in there in the parentheses, now I go back to my main chain of my molecule. I have CH2 going to CH2 and CH3 and CH3. So I use parentheses here to indicate that that goes off to the side. Another way to show the condensed structure is actually to show the CH3 group off to the side. Either of them is correct. The one on the left is what we use much more frequently, and when you're doing condensed structures on mastering, that's exactly what we want to do, is this more abbreviated version. Now let's work one of these out. How do we get from our Lewis structure to a condensed structure? I'm only going to show it in the way that we looked at first on the previous one, using the parentheses, rather than the second way, the method on the right, because the one on the left is what you're going to be expected to do on your mastering homework. So what I want to do is I'm going to read my molecule from left to right. I'm going to start here with my CH3, and so I'm going to write CH3, and then I'm going to go to my second atom there. I have a CH, and I see that on the side I have a methyl group, so I'm going to put that in parentheses to let me know that that carbon group is off to the side of the molecule, so I have CH3. I'm going to go to the next carbon. I have a CH, but I notice I also have a Cl. I'm going to put that in here. Now, notice that on the CH3 I used parentheses, and the Cl I did not use parentheses. That's because our halogens are always terminal atoms, just like our hydrogens are always terminal atoms. I don't have to put parentheses around the hydrogens to indicate that they are attached to the carbon and not a part of the chain. But for methyl groups or other alkyl groups, I do need to include those in parentheses because the carbon could be part of the chain, but I want to make sure we're clear that it is not part of the chain. So terminal atoms that are atoms that are always terminal atoms, like hydrogen and chlorine, do not need parentheses, and it would be incorrect to use them since they are not needed. So now I've got my CHCl. Now I can continue with the molecule. I have CH2, CH2, and CH3. And I simply read my molecule from left to right, putting in my side groups as I came along. Now I'm going to look at how we get from a condensed structure to a skeletal structure. The first thing I want to find out is how many carbon atoms are in my backbone, in that main chain or that main part of my molecule. So I'm going to go through the structure, and I see carbon 1, I see a second carbon, a third carbon. I note that this in parentheses is part of my a side group, so I'm not going to include that in my base chain or the main chain of my carbon atom. So I've got 3, I have 4 carbons and 5 carbons. So now when I draw my structure, I have 1 carbon, 2, 3, 4, 5. And so we can go back and check this. So there's 1, 2, 3, 4, 5. You don't need to actually color in anything or make it look different on your structures. I was just showing it there to show how I was counting those out. So we have 5 carbons in our main chain. Now I go back to my chain and look for any side groups. Now I'm not going to draw in the hydrogens because we know we're going to put hydrogens in to fill up those 4 bonds. So what I see now is that I have a bromine as a side group. It's on the first carbon, so I can add that to my structure. So I have a Br. Now I do need to put the symbol there because I need to know that that's a bromine and not a carbon atom. Then I get to my third carbon, and I see that I have an ethyl group. This is a 2-carbon group, and so I'm going to count to my third carbon. So I have 1, 2, 3, and we'll talk more about counting carbons and how we look at that in our nomenclature activity this week in class. But for now, just know that we're at the third carbon here, and I'm going to draw in my ethyl group. Okay, And I'm actually going to do that just by putting a bend here because that represents a carbon and that represents another carbon. Again, the blue dots are just there so you can see where I'm counting. So now what I have is a 5-carbon sequence here in the background, the backbone. I have a bromine atom off of the first carbon like it was shown in the condensed structure, and I have an ethyl group shown here off of the third carbon. Note that this is an ethyl group because I have it all in one parentheses. If I had 2 methyl groups, I would actually show it as CH3 2, and that would represent the 2 methyl groups off of this one carbon atom. But we have 2 carbons both in the same parentheses, so we know we have an ethyl group. Now we want to go from the skeletal structure to our condensed and Lewis structures. And so there's a couple of different approaches we can take, but the first thing I'm actually going to do is go through and draw in all my hydrogen atoms. I'm going to put those in a different color because I really don't want to draw all of those hydrogen atoms. And so what I'm going to do is just draw in these lines to represent that each of those little red lines represents a single hydrogen atom. Now this carbon atom has 3 red lines because it needs 3 hydrogen atoms because it only has 1 bond here and it needs to have a total of 4 bonds. Now I'm going to go to my next carbon and I see that it already has 3 bonds. So this carbon has a bond here, 1, 2, and 3. And so I need to add 1 hydrogen there so that that carbon has 4 bonds. I go to my next carbon, it has 2 bonds, so it's going to need 2 hydrogens, so it has a total of 4 bonds. My next carbon has one spot open, needs 1 hydrogen. This needs 2. This carbon needs 3. This carbon needs 1 because it has 2 bonds to carbon atoms and a bond to fluorine, so it only needs 1 hydrogen to finish out its quartet of bonds. We need 2 hydrogen atoms on that carbon and 3 here. Oops, forgot that one there. We need 3 on that one as well. So now I've kind of drawn in all my hydrogen atoms, so now it's going to be a little bit easier to write out my condensed structure since I can see how many hydrogens are involved with this. So I'm going to start again here on the left of my molecule, and I'm going to start by reading the molecule and writing down what I see. So for my first carbon I have CH3. The next carbon I have CH, but I also have a methyl group off to the side. I'm going to include the parentheses to indicate that that carbon atom is not part of this chain, but rather is a side group here. Then I go to my third carbon, I have CH2. Next I have CH, but now I have a side group on this carbon, and I'm going to write this as CH2, CH3 because it's an ethyl group. It's a 2-carbon group there. Then I go on to the next carbon here that also has a side group. So I have CH and F. I don't need to put parentheses around the F because that fluorine can only be a terminal atom. It could never be part of this chain. And then I go CH2, CH3. So now what I have is the entire structure condensed into this one big formula. Now I'm going to show this as a Lewis structure. Now, for the Lewis structure, I know I'm going to retain some information in the way the atoms are connected. I'm going to actually show that connection as opposed to the condensed structure that kind of shows things in parentheses. So the first thing I'm going to do is look for the backbone of my molecule. And I'm going to start here with carbon 1, 2, 3, 4, 5, 6, and 7. So I have 7 carbon atoms. And so I'm actually going to write that 1, 2, 3, 4, 5, 6, and 7. And now I'm going to start kind of filling in what I need around it. And so I can put in my hydrogen, hydrogen, hydrogen. This one has a hydrogen. It also has a methyl group, and I'm not going to show all the hydrogens expanded on that just to save a little bit of space here. My next carbon atom has 2 hydrogens. The next carbon atom has a hydrogen and an ethyl group, so CH2, CH3. Again, I'm not showing those expanded out just to save a little bit of space here on the screen. The next carbon atom has a hydrogen and it also has a fluorine atom. My next carbon has a hydrogen, and then I have a hydrogen, and hydrogen. So now we're seeing kind of the expanded or almost expanded version where we're showing all the atoms connected. But the thing to do before I go to either the condensed or the Lewis structure, I always want to go through and draw in those hydrogen atoms on each of those. So if I'm looking at a skeletal structure, it's always very useful to go in and draw those in. It makes it much easier to start counting the hydrogens here rather than when I'm actually drawing out these alternative structures.